enter in the rear from the queue will always it will always occupy the first position. That means the first element which I am going to enter will, let's take an example, I enter A. Now when I enter A, the rear will point to 1 and the front will also point to 1. After that, if I enter second element, say B, it will enter from here and will come to this place. Similarly, I want to enter the third element, it will come to here, C, and so on. Now, once I am going to delete one element, what happens? I will be able to delete this element. Let's say I want to delete one of them. I can delete this A. Now, if I am going to delete this A element, it is going, that means now the front pointer will point to B and the rear pointer will point to C. Now here, at this point of time, the front pointer will point to here and the rear pointer will point to here. Now I will just remove that one because just to so that you will not be confused with this. Now this is the status of the queue right now. Now if I want to enter any more element, for example, I want to enter say R, obviously you will enter here. And in this case, now what will happen? The rear pointer will now point over here. Now I want to enter one more element. I will be able to enter say K. And here now the rear pointer will point to this place. The rear pointer will now point to this place. Now at this point of time, I want to enter one more element. I want to enter one more element. But there is no space after K. Therefore, at this point we say that the queue is full. Though you might argue that there is a space at 1 which is there. But here R is incrementing from 1 to 2, 2 to 3, 3 to 4 and 4 to 5. 5 is maximum, therefore I cannot move from 5 to say 6. And therefore, at this point of time, the queue is full. Therefore, this is called a normal queue. It's called normal queue, where it is just like when you stand on a bus stop, it is basically a normal queue, where you are standing in one line. Now, always everybody who is going to stand in a queue will be in a single line only. Okay, but it happens that you can visualize a normal queue to be a circular queue also. A circular queue is nothing but where I can put a queue like this. And I can put like this. Let's take 1, 2, 3, 4, and 5. I can put like this 1, 2, 3, 4, and 5. What I did, I just joined both the ends together to make it like a circular queue. If I'm using like this a circular, you can see that I can very well point from 5 to 1 because 1 is adjacent to 5. Okay. Now, there is no difference between those two. If you see over here, if you are going to see, these are both same. except that I have joined both the ends together. And here, if I
सर आपकी आवाज नहीं आ रही है।
वीडियो और ऑडियो दोनों चले गए, वीडियो पॉज हो गई है।
वाईफाई बैठ गया सर का। नहीं वाईफाई वीडियो चल रही है, बोर्ड चल रहा है।
कॉल करो कोई सर को, जिसके पास नंबर है सर को कॉल करो। उसे तू कर ले सर को कॉल।
सूर्या इधर, सूर्या को बोलो करो यार कॉल।
सर तो रुक ही नहीं रहे हैं, चलते जा रहे हैं।
ये चैट बॉक्स देखते हैं क्या?
रुक मैं
नहीं,
करता
चैट बॉक्स नहीं
हूँ।
देखते हैं।
वो कॉल करता हूँ, देखता हूँ क्या
कस
चलेगा
के आवाज
वैसे।
लगाओ, कस के आवाज लगाओ।
चिल्लाओ एक बार जाके खेत में उधर से साइड से।
सर
जी बोलो बेटा।
कौन बोल रहा है?
मेरे को ये समझ नहीं आ
सर
रहा
आपकी आवाज नहीं आ रही।
95 बनते कहाँ से आए क्लास में?
अबे यार ये तो सुन नहीं रहे हैं।
कॉल किया
Bear
जाए?
in mind that this is being recorded, bro.
कॉल किया जाए क्या?
ये उठा रहे सर, मैंने करी है।
रिसीव भी नहीं कर रहा है ऐसा?
नहीं वही तो कह रहा हूँ, नहीं कर रहा है। कैन नॉट रिसीव आ रहा सर का।
हाँ
व्हाट्सएप कॉल कर दो सर को।
व्हाट्सएप से भी क्या फायदा है?
अरे व्हाट्सएप तो जाती है ना, व्हाट्सएप ब्लॉक नहीं होती।
is the voice clear now?
सर स्टार्टिंग से आपका माइक बंद हो गया था।
तो किसी का फोन आ जाता है ना, तो पता नहीं किस प्रॉब्लम हो जाती है। अच्छा अब बताओ, नाउ इट्स क्लियर?
यस सर, अब ठीक है।
कैन यू सी द प्रेजेंटेशन?
सर पहले थोड़ा सर पहले से करा दो, हमें बीच में आ नहीं रही थी आवाज।
सर जूम हो गया क्या फिर?
तो स्टार्ट से ही आवाज
अब
आपकी
ठीक
बंद
है
हो गई थी।
सर
it's
थोड़ा
okay?
और पहले,
सर
और पहले सर यहाँ से सर, मतलब जब आपने सर्कुलर क्यू करा था ना, तो उसके
हाँ
थोड़ी बाद ही आवाज रुक गई थी।
ठीक है, नाउ फाइन। नाउ दिस इज द सर्कुलर क्यू। A circular queue is a extension of a normal queue. Now it means that this was okay, that this is normal queue. Now if you see, this is normal queue. This is normal queue. Now here what I am doing, I am joining the both the ends together, and therefore when I join both the ends together, it becomes a normal a circular queue. Now, circular queue is just a visualization. There's nothing which is we say that a circular queue exists in the real world. That means physically it doesn't exist. But you are just visualizing it to be a circular queue by joining the last and the front end together. Why? Because here, if I want to go from 5 to 1, you will find that those two cells are not adjacent. Whereas if I draw like this, if I'm going to draw it as a circle, you find that 5 and 1 are adjacent. You know that very well. In memory, it is always in a linear queue or linear memory. For example, when you talk about RAM, each of the cell of the RAM will be having, it's always linear. But when we try to do it in a circular manner, we have to visualize in our programming language or in our algorithm. That when I talk about those things, we say that this is now what happens in normal queue. If I am going to put an element from K after K, I cannot put because there is no space over there. But in a circular queue, there is space over here. Therefore, I can very well put, say, after 5, after 5 I can put at 1. Similarly, if I delete an element over here, let's take an example. If I delete an element, say, like this. If I can put some elements over here, I can very well put like this. If I delete from F, I can very well put at that position. Now, if all the elements are full, now in that case, let's take an example. I put P over here. Now I put, say, I put P. Now I find that now the queue is full because now all the elements are, all the spaces are occupied, and therefore this is a circular queue is also full. Now this is the actually whenever I talk about say queue, it will always be a circular queue. Therefore, whenever I talk about queue, you always think it to be a circular queue, and normal queue will never be existing anymore. Therefore, in all my classes, whenever I talk about queue, you think it to be a circular queue. Now, this is how we are trying to do. That means whenever I am going to use this queue, it is basically like this. You can reverse it 180 degree. Doesn't make a difference. Either you can put a front at this side or rear at this side, or you can interchange it like this. Doesn't make any difference. You are just rotating it by 180 degree. Therefore, this is how you are going to visualize a queue. Now you can implement a queue as a static allocation or as a dynamic implementation. Now, just to make sure that if you are using a static allocation, I will write like this, say integer queue of say 10. Now, if I am going to use a dynamic allocation, I will write integer star of q. Q is equal to now assume let us take one integer takes 4 bytes, that will be 40. Now this is a dynamic allocation. That means I take that 4 into 10, that is 40 bytes. If you are using an ANSI compiler, it will be 4 into 10. If you are using a turbo compiler, it will be 20. Okay. Now after this, while reading a queue, you know that you have to use a for loop. In any of the questions, we have to use a for loop. Now, if I'm using a for loop over here, those of you, you can write like this for Correct? This you are going to read a Q. For this one also, it will be same, but a small difference what I can write. Now, just to make you aware that this whole two lines can already be posted, can be put over here. But instead of, if I'm writing using a thing, I can write over here, I can write the same thing over here. And for this line, I can write a scanf. Is it clear? Or is it wrong? Something is wrong. Shall I write Q plus I or ampersand Q plus I? Batao. Is this clear? Is this correct?
No, sir.
What does Q points to? What does Q points to? It points to the first block of memory. Okay, let us take an example. Let us take Q starting block is suppose 2500. Let's take an example. Q the starting block of Q is 2500. That means when I say Q plus 0, Q plus I, it is nothing but 2500 plus I0, therefore it will be 0. Because you start with I is equal to 0, therefore it will be 2500 plus 0. Whatever you are going to put from there, you put from the keyboard, will put at 2500 plus 0, that is nothing but 2500. Now, those of you who are not very conversant in pointers, try to understand this line very well. Now, in the second time, when the loop iterates from I is equal to 0 to I plus 1, this will become Q plus 1. That is nothing but 2500 plus 1 will be how much?
Yes, sir.
Now, some of you might think that what is this mathematics? It's very pure, correct mathematics. If Q is a pointer, pointer plus 1 means the starting block of the second element. Therefore, don't confuse with a normal mathematics. Your 2500 plus 1 will give you 2501. It will give you depending on the size occupied by Q. Therefore, 2500 plus 1 will give you 2504 because integer takes 4 bytes. Similarly, if I write Q plus 2, it will be 2500 plus 2 will give you 2508 and so on. Now, this will answer my question in the last class when you said that what is a void pointer? Now tell me, if Q would have been a void pointer, can I write like this without knowing that what is the value of data stored at that location? That means, how can I know 2500 plus 1 will be either 2501 or 2 or 4 or 8 or anything? Therefore, when you are going to use a void pointer, Q as a void pointer, I have to know what is there. Now here, I can use, instead of writing this, I can also use a void pointer over here. I can use a void pointer. Though it will not be wrong, you can use like this also. But the problem is that you cannot know what will be the value of Q plus 1 until you know that q is pointing to an integer. If this is an integer, this is correct. If this is float, you have to take it increase by say 4. If it is say a double, you will increase by 8. If it is a character, you increment by 1, and so on. Therefore, void will also solve the problem, but you have to keep in mind always that if q is only pointing to an integer, this is fine. But if q points to an integer sometimes and points to a float sometimes, points to a character sometimes, you have to keep in track that what it actually points to. Otherwise, you will not be able to find the things. Now, this is the way you write. Okay. Now, one question with for you. I write I of q. Is it correct or wrong? Can I write like this? It is correct. You can write like this also. Now,
No, sir.
you might ask me, huh?
How?
No, you try at home. It is perfectly valid. Now, that is the point what I wanted to discuss you. And please keep in mind that when I write I of q, you might look that it is something interpreted as 0 of q. Somebody is coming. Tushar Jaiswal. Now, if I write like this, 0 of q, now I already told you that here q is a pointer. Now, 0 of q will be interpreted as 0 plus q. Is there any difference between 0 plus q or q plus 0? No.
No, sir.
No.
Therefore, even if I write like this, I of q or q of I, it is interpreted internally by the compiler as 0 plus q or q plus 0. If you write q of I, it is interpreted as q plus 0. If I write 0 of q, it is interpreted as 0 plus q. Therefore, even if you are using it as an array, internally the compiler is treating it as a pointer only. And therefore, this is perfectly valid. Though in the books it is written that this is the way to write, but if you are writing in a program, it is perfectly correct. Because the compiler will not take as I plus q, q of I as an array. It will treat as a pointer. You are treating it as an array. Similarly, that means even if I write it over here like this, even if I write like this, it is perfectly valid. Even I am using q as a pointer. Now here you find that I am using q as an array. Here I am using q as an array. Here I am using q as a pointer. But this is perfectly valid. Because you can use interchangeably q of I or q plus I, you can use it interchangeably. But the compiler will treat q of I as q plus I only. Okay. Now that's a very important thing, that in a program you might declare q, you might declare this as you might declare it as a pointer, but use it as an array. But only thing is that if you are using it as an array, you have to prefix this ampersand sign. While using it as a pointer, if you are using like this, you have to put an ampersand sign. If you are using it as a pointer, you don't require to put an ampersand sign, because here q of I means the ith element of q. Therefore, for finding the address, you have to put an ampersand. But if you're writing it like this, Q is itself a pointer. Pointer plus that value, this is nothing but the interpretation is like this. Therefore, don't put an ampersand sign, because here Q is itself a pointer. Here it is a pointer but interpreted as an value. Now just to make sure that if I am putting a cell like this, say if I put a cell like this and I put a value, say 10. Now this will have first of all the name, then you will have the address, and here you will have the value. When I put Q of I, it takes the value. If I take this Q of I, if I use like this, it will give you the value. If I put without an ampersand, it takes an address. And Q is the name of the array. Therefore, when I say I write integer star Q, we say Q is the name, but actually Q is points to an address. Now here, if I take this like this, Q is the name of the pointer, but actually Q holds the address. It holds the address. Therefore, this is the whole thing. Whenever you are going to declare a variable, any variable, not in a pointer, you simply write integer star A. You write simply like this: integer. Sorry. Right, I write like this: integer star A. Now here you will create a memory map like this: A, some address, maybe say 2500. Maybe some address like this, say 2500, say 20, and we'll have some junk value inside it, some junk. Therefore, obviously, memory cannot be blank. There'll be some junk. There'll be some junk. Maybe you will have some junk value. Now, once you write A is equal to 50, now you replace that junk value with this. Therefore, memory can be either zeros or ones. You know that it will either contain zeros or ones. Therefore, in any case, it will not be a. It will.
सर की आवाज आ रही है?
नहीं आवाज नहीं आ रही।
अब कैसे बताएं सर?
हाँ,
आ गई।
anything you want to ask?
सर वो आपकी आवाज चली गई थी।
Now, it is a non. असल बीच में फोन आया था, अब उसको I have to manage some. I put a camera with. I'll put a phone record, because right now the camera is not installed properly. If I'm using a phone, from next class onwards, I'm going to install a webcam. Therefore, that will solve this purpose. Therefore, whenever a phone will come, the voice will not be there, but after it will be okay. It takes around 5 to 10 seconds. Now, a tree can be defined as a finite set of data items on node. Tree is a nonlinear type. Already know that. When the data is stored in a sorted sequence. Now, when I talk about sorted sequence, the sorted may not be 1, 2, 3, 4 like this, but whatever sorting is there, that is based on relationship. Therefore, trees, the main concept is that it always represents a hierarchical relationship. All trees will represent a hierarchical relationship. Now, in that case, a tree can be like this. Therefore, if it contains maximum of 2 nodes, it's a binary tree. If I put, say, maybe say 3 nodes or 4 nodes or like this, I can put n number of nodes. This is a tree, but not a binary tree. Therefore, this is called an n-array tree. It's called an n-array tree. Where n is always bigger than 2. N is bigger than 2. It could be trinary tree, it could be tetranary tree, but we don't use those words. We only use the word binary tree or n-array tree. N-array means it could, if a node can have 3 child, therefore it will have 3 children, then it is called an n-array tree with n is equal to 3. If it is having a node can have up to say 10 children, we'll say it's an n-array tree with n is equal to 10. And therefore, this is general definition of a tree having a maximum of 2 children. Maximum of 2 children doesn't mean that it has to be necessarily 2 children. Maximum of 2 children is a binary tree. If it is having more than 2 children, it is an n-array tree. In this class, we'll study the binary trees and the n-array trees. The binary tree will be there. A lot of trees like this we'll study in the class. For example, a binary search tree, a Huffman tree, an AVL tree. Then we have that is called a height balance trees. Then we'll study about n-array trees like B trees, B plus trees, and there are a lot of things which are there in the syllabus. Now, whenever I speak trees, it means binary trees. That means binary means 2. Therefore, whenever if I do not specifically say n-array tree, it is always a binary tree. Therefore, in those cases, all trees are binary trees until explicitly told by me that this is not a binary tree. Okay. Now, in most of the classes, we'll follow the binary tree only. We'll follow the binary tree only. Now, this is the definition for a tree is a special data item at the top of the hierarchy called the root of the tree. The remaining data items are partitioned into a number of mutually exclusive subsets, each of which is itself a tree, which is called a subtree. Now, here what he is trying to say is that whenever I draw a tree like this, now this is called the root. And partitioned into a number of mutually exclusive subsets. That means there are 2 over here, one like this, another like this. Mutually exclusive means either if you move to the left hand side, you can only move to either any one of them. If you move on this side, you can only move on 1, 2, or 3. You cannot go to this side. If I move from root, I move to the right, I can only go to either 4, or I can go to 5, or I can go to 6. I cannot move this side. Once I move to the left hand side, I can follow all the nodes on the left hand side. Therefore, if you come to 1, you will miss all those nodes which are from 4 or from downwards to 4. If you move to 4, you will miss all the nodes from there. Therefore, it is mutually exclusive subsets. Now, subset means from the root, it will be one subset is 1, 2, 3, other subset is 4, 5, 6. And therefore, now this is itself now a tree. Now this is itself a tree. Therefore, we call it a subtree. Now we call it a subtree. Now this is another subtree, is another subtree. Now I can write say subtree. That means each of which is itself a tree called a down. Now if I move downwards, again I find this is another subtree. If I move downwards, I find this is another subtree. And this definition is recursive. You come to any point, you will find a new subtree. You again move until unless you come to a leaf node. Leaf node is a node which does not have any child. It means 2, 3, and 6 are leaf nodes. Now, when you come to leaf nodes, you find that they do not have subtrees. And therefore, we keep on moving now. Why it's called non-linear? Because once you move from root to left-hand side, all the nodes on the right-hand side need not be traversed or need not be visited. Therefore, in that case, these nodes are basically nodes which are partitioned from partition to 2. Now, a tree always grows in length towards bottom in data structure, unlike natural trees which grows upwards. Now, when you find a natural tree in your garden, it grows from bottom to top. But here, it grows from top to bottom. That means it always grows from the top to the bottom. And therefore, if you rotate by 180 degrees, it could be a tree of a garden. But here, the root is at the minimum level in the tree in your garden, whereas this root is at the highest level. Now, if I want to draw a tree of a family tree, the root will be the person who is the highest or the senior most person in your family. Now, the problem is that a root there can be no two roots. And that is one of the limitations of a tree. For example, you might be having your great grandfather and your great grandmother, or your grandfather, your grandmother. You cannot depict grandfather and grandmother as two different roots. You have to devise some method to justify the relationship. That will root here means your grandfather or grandmother, or you can use a combined way. But I cannot make these two roots like this. Where this is your grandfather, this is your grandfather, and this is your grandmother. I cannot do this. I have to combine this only and generate one thing. Say I can write grandparents. I can write grandparents. And now grandparent will become a root. Because there is no way, because if I can put it like this, two different ways, to different roots, it will be difficult to find that which of the child related to grandfather, which of the child related to grandparents. Grandmother, sorry. Now this is what I am talking about. Now one thing you should remember, at this position you will have 2 to the power of 0 number of children. Here you will have 2 to the power of 1, and this will contain 2 to the power of 2. Now in that case, it means that if the tree is having a height equal to 3, now here I will come with a word height. The tree is having a height equal to 3, and at the first position, it will be equal to the number of child will be 2 to the power 0. Then at the second height, now here if I say h is equal to 1, height is 1. Here h is equal to 2. Here h is equal to 3, height. And the number of nodes at a particular height is given by formula of 2 to the power of h minus 1. And this is the maximum number of children that can happen in a tree. That if I ask you, what is the maximum number of children on a particular height of a binary tree, you will say 2 to the power of h minus 1. What is the total number of nodes which can be there in a tree of height h? Now try to understand the question very well. What is the maximum number of nodes which can appear at a particular height or in a binary tree, it is nothing but 2 to the power of h minus 1. If the height is 2, it is 2 to the power of 2 minus 1. If the height is 3, it is 2 to the power of 3 minus 1. But if I ask you, what is the maximum number of nodes that can be there in a tree of height h? The formula for this will be 2 to the power of h will be 2 to the power of h minus 1. Now here the height is 3, therefore it will be nothing but 2 to the power of 3 minus 1 will give you 7. And there are 7 nodes. Now here is the question. If it had not been a binary tree, suppose it's a n-ary tree with height 3, then you replace this 2 by 3. If it is a n-ary tree with n is equal to 5, you replace this 2 with 5. And therefore, this will be just replaced by, this will be replaced by n. Now here, this will be replaced by n. Now here, this 2 will be replaced by n over there. Some flaw. Now you can replace this with n, where n is the n-ary tree for this. Now this is general rule. The number of nodes in a tree of height h is 2 to the power h minus 1. If it is not a binary tree, it is n of power n power h minus 1. That means this is which you are asked in the questions. That now the question comes: what is the minimum number of nodes in a binary tree of height h? Now I want the answer from you. What is the minimum number of nodes in a binary tree of height h? This is the maximum. So what is minimum?
H no.
बताओ.
H.
Please repeat. H. H. Okay. Now in that case, it will be, because the tree will be like this. Maybe like this. It could be like this. Therefore, the minimum number of nodes in a tree of height h is h. The maximum number is 2 to the power h minus 1. Anything in between, it could be anything in between also. Or it could be like this. Or it could be like this.
Sir, this maximum is only for a binary tree.
No, or if it is not a binary tree, it will be h only. Now in that case, if I use h as, in any case, this h will remain fixed. But if it is,
No, sir, I'm talking about the maximum, sir. 2 to the power h minus 1.
Maximum, of course, it will be only for a binary tree, because
Yes.
2 is coming. If you are
Yes.
taking for an n-ary tree, you place 2 by that number.
Yes.
If I take, say, an n-ary tree with 5, you write 5 of h minus 1. Therefore, that will be same. That means in that case, H stands because of being its binary. If it is not a binary, it will play by that number. Okay. Now this is the whole. Now you must understand that why I said it's a non-linear, because once you are coming from this place to this place, all these are skipped, and to go to C D, you don't need to skip B and C both. You just need to skip B. If I want to go to G, I will directly go from A to C to G, and not A, B, C, D, E, F like this. That means if I want to come to G, I start from A, come from A to C, from C to G. I don't have to skip from A to B, B to C, C to D, D to E, E to F, or G. If this would have been a linked list, or it have been an array also, you should have skipped one by one from A to G. Therefore, time to reach to G in a linked list will be 7, because you have 1, 2, 3, 4, 5, 6, 7. Whereas the time to reach to G in a binary tree of such a structure is only 3, from 1 to 3. Okay, but time I am saying is not the time. I'm just saying the steps. Don't try to confuse with time means that if I take 1 second or 3 seconds, not like that. Just the number of steps you require to read over here is only 1, 2, 3. Okay. Now I'll make further additions to this. How much time you require to reach to any nodes of a tree is equal to h. So how much time you require to reach to any node of a tree is equal to h. Since the height is 3, any node can be reached in 3 steps. If the height would have been 10, the number of steps, maximum number of steps to reach to any node of a tree will be 10. Will be 10. Now one definition is important. If every node of a tree has a maximum of 1 child, that tree is called a skew tree. If every node of a tree has exactly 1 child, it is called a skew tree. Therefore, this is a skew tree. This is a skew tree. This is a skew tree. Every node you will have exactly
सर का ऑडियो नहीं आ रहा मुझे, तुम लोग आ रहे हैं?
सर शायद अपनी फोन वाले आईडी से तो लेफ्ट ही कर गए।
Now Facebook graph is different. Now this is the one which I drew over here. The one which I drew over here is a graph. Is a graph. Here there is one teacher and the n number of students. Now, if you take the Facebook graph, it will be a little different. It will be something like this. Like this. Suppose this is you. This is say you A. You are having friends B. You are having friend C. There is a friend D, and there is a friend E. You are not connected to A to E, but you are connected A to E via B, C, and E. Now this could be a Facebook graph. This could be a Facebook graph.
सर
और एक ट्विटर. हाँ बोलो.
सर आपने ग्राफ जब स्टार्ट किया था आप मीटिंग लेफ्ट कर गए थे
No, this
तो
is the
सर
first slide. This is the
आवाज
first slide
नहीं आई
only.
थी आप जब आपने स्टार्ट किया था तो
सर फिर से वही हो गया।
अरे फिर से चलेगा व्हाट्सएप कॉल करो सर को व्हाट्सएप कॉल पर चलती है मैंने भी कर दी सर ने कॉल भी काटी थी
अरे 1:10 बज चुका है यार।
फिर लेफ्ट कर गए सर
किसी को सर का साउंड आ रहा है?
नहीं
सर को बोलो भाई कि साउंड लेके आए, कुछ नहीं सुनाई दे
सर
रहा, वो पढ़ाई किया जा
कैसे
रहा
बोले
है।
कैसे बोले तू बता
इतना पता मैं खुद ना बोल दूं, तुम कुछ जुगाड़ बढ़ाओ।
वही तो सर को कॉल करा मैंने व्हाट्सएप सर पर काट रहे हैं मतलब पता नहीं सर को याद कोई नहीं पता
कॉल करने से भी दिक्कत हो जा रही है ना इसलिए रिसीव नहीं कर रहा है।
अरे तुम नॉर्मल कॉल करोगे ना तो दिक्कत होगी व्हाट्सएप कॉल पे दिक्कत नहीं होती पर मतलब व्हाट्सएप कॉल सर काट रहे हैं
अच्छा। शायद अभी क्लास ले रहे होंगे इसलिए काट रहे होंगे क्लास के बाद लगता है।
हाँ वही है
ये नहीं पता होगा कि क्लास वाले ही कर रहे हैं कॉल।
सर तो पढ़ाए जा रहे हैं भाई।
यार कॉल भी तो नहीं उठा रहे सर, क्या करें? व्हाट्सएप कॉल करूँ एक और?
हाँ ट्राई मारो ऑफिशियल ग्रुप पे या फिर करो कहीं व्हाट्सएप मैसेज पढ़ ले।
ऑफिशियल ग्रुप पे सर को पर्सनल पे डीएम कर दिया यार मैंने, ऑफिशियल पे तो देखे ना देखे, पर्सनल पे कर दिया मैंने तो।
कर दिए?
हाँ पर्सनल पे कर चुका हूँ मैं।
इतना पढ़ाने में बिजी है देख भी नहीं रहे।
कौन कितना यार।
सर तो टाइप्स ऑफ ग्राफ पे भी पहुंच गए।
वही तो भाई, आगे चले गए सर तो।
ग्राफ खत्म करके मानेंगे फिर बोले चलते हैं, तब आ जाएगी लास्ट में।
सर को बोल देंगे सर कल ग्राफ फिर से पढ़ाओ, कुछ कुछ समझ में नहीं आया ना कुछ सुनाई दिया।
कॉल काट रहे हैं सर, पता नहीं चल रहा।
सुनाई तो किसी को ना दे रहा है।
कुछ भी नहीं देख रहा है, कमेंट बॉक्स तो देख लेते कम से कम, चैट बॉक्स यहाँ पे।
और कमेंट वो दिखेगा नहीं ना सर, दूसरी स्क्रीन पे शेयर कर रहे हैं वो दिखता नहीं जब शेयर करते हैं तो। आ गए सर, आ गए। व्हाट्सएप कॉल करने में सर आया था। अब माइक बंद है सर का।
खत्म हो गया तब है।
सर माइक, योर माइक इज ऑफ सर।
हाँ, now it's fine. Okay.
सर 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 दो स्लाइड पहले से सर आपकी आवाज चली गई थी, मैंने आपको मैसेज भी किया है।
सर ग्राफ शुरू से सर।
पहले सर ग्राफ स्टार्टिंग एक और पहले सर, आप ट्विटर एफबी एग्जांपल लिखा था ना आपने जब वहां पे, तब वहां से इससे
Here.
यहाँ ये सर आपने ट्विटर एफबी लिखा था ना, तब आपकी आवाज चली गई थी।
Okay. Now a Twitter graph will be like this. This is a Twitter graph like this, where you might follow somebody and some person might follow you, and therefore it's a two-way graph. You might follow say 100 people, but you are being followed only by 10 of them, and therefore that's a complex type of graph. Relationship exists. It will have a complex relationship. Why? Because you might be following 100 of people, you might be following a lot of celebrities, but those celebrities might not be following you. But you are having a friend of you who you might be following your friend, and that friend might be following you. Therefore, in this case, this could be like this. And some of them will only be like this. Something like this. Therefore, it is a graph which have a double edge or whether a single edge. Therefore, this is a typical type of graph. A Facebook graph will be something different, where you are having your friends, and that friend also your friend. Therefore, it's a two-way thing. A WhatsApp is something like this. All of you are connected among yourself. This is strongly connected graph. For example, it will be something like this. Like this. Everyone is connected to everyone. You can send your message to everyone. Now, in that means, if it is if there are 4 nodes or 3 nodes, it will be something like this. All of you are connected with one another. It is called a strongly connected graph. This is called a strongly connected graph. Now, one thing, now this is the one which I said, that a weighted graph is a graph where each and every edge is having a weight. If I draw without an edge, without an arrow, it means it's a two-way. It's a two-way. That means there is a road from Delhi to Hyderabad, and there is a road from Hyderabad to Delhi. Therefore, I don't need to draw the arrows. But if I have a one-way road, I will say that I will only draw an arrow. That means, for example, there is a road from Delhi to Chandigarh, but still no road from Chandigarh to Delhi. I have to draw a single arrow. So that's not a practical example, but you can find in Delhi there are a lot of one-way roads, and one-way roads you have to draw an arrow with this. Now this is the directed graph and the undirected graph which I talked about. Now, let us take for this. Now, this is a directed graph. You already know you are giving an undirected graph, a simple animated graph. Now, connected graph is a graph where all the nodes are connected. Now I drew one more graph over here. Just when, okay.
Sir.
Okay. Now this is a graph. Now this graph is a non-connected graph. Now can you tell me that where you will find the application of this graph? How did I draw this type of graph? In what scenario you will find that this graph is there? How will this graph be generated? For example, I want to draw the roads of India. Okay. There could be some roads which are not connected to India. For example, there is an island Andaman and Nicobar. Now the road inside Andaman and Nicobar cannot be connected to the rest of India because of water over there. Therefore, this could be a road of Andaman Nicobar Island. This could be a road of Andaman Nicobar Island. And this could be a road of the rest of the part of India. And there is no connection between those two by roads. And therefore, this is a non-connected graph, but all the roads belong to one of India only. Therefore, this type of roads is a non-connected graph. Okay, that was the last slide. Therefore, this is the actual whole coverage that we have covered. The basics of stack, queues, linked list, trees and graph, and that is the entire syllabus of the whole semester. That we'll study over here. These all the 5 topics are there, and their subtopics. Now, graph and trees is a bigger chapter. Therefore, it will take around no less than 10 classes. Rest of them will do it in 7, 8 classes. Now, anything you need to ask, you need. I will be using that thing. Therefore, if you want to ask any questions, you are free to ask them.
Thank you, sir.
Okay.